right, everybody. Good evening. Welcome to 2017 or 2017. Tonight's demo is Neal Brandt. He's going to be doing TippeTops. He did this at SWAT last year.
Year and a half ago.
Year and a half ago. So he's going to be doing that for us. Neal?
Thank you. Thank you. I was told I have about an hour, so I'm going to hurry a little bit, but it doesn't take long to make a top, so it shouldn't be a problem. What I want to do is make a TippeTop tonight and show you how to do it to make them work. Here's a regular top, and regular tops are nice. You spin them, and they're stable. They just kind of stay there. They may precess a little bit, but it kind of defies gravity. And that's I think they're fascinating. But when I learned about what a TippeTop was, I was even more fascinated. So let me show you a TippeTop. Here's one. This is maple dyed. And what happens when you spin these is you give it a good spin, and it defies gravity even more, because what it does is it flips upside down and turns on its stem. So what I want to do tonight is show you how to make them so that they'll do this most of the time. I haven't figured out how to do it so that every time they work. I mean, some of them I make and I just can't get them to work. That happens occasionally, and it may happen tonight. But I don't think so. I think I'll be able to make one that works. So what I'm going to do is pass a few of these around. So I'm going to pass...
Hey, John, can you pass stuff around? Yeah.
So you want to pass this to one section. And you can try it if you want. You can see what the top looks like. And let me give you another top with this one. Let's see, some of these work better than others. I think this one works pretty well, so I put that one on. And a lot of these tops, they're fun to make. You can make them out of an exotic wood, like this one's out of Ambonia burl, and it has an ebony stem on it. This is maple that's painted and textured a little bit, and I'm going to make one kind of like this tonight. Why don't we pass that around? Here's one that I scorched. This is ash. I scorched it, then put some of the Jimmy Clue's cream in it for the silver color. Here you go. You want to pass that around? I want all these back, by the way. Here's a kind of an interesting one. What's this going to look like when it's spinning? Can you see that? It's got walnut, maple, and ebony. So what will it look like when it spins and flips upside down? Well, it looks like it's looking back at you. It looks like an eyeball. Okay, so that's another one. I'll start that one. I don't know. Maybe that's enough. Here's another one. I'll start that one too. So that's what a TippeTop is, and that's what it's supposed to do. Okay, so here's the question. Why should you bother to turn a TippeTop? Well, I think you can see that they're interesting, that they flip over like that. But there's some other features they have that make it kind of appealing to make. One is they're quick to turn. You can turn a top like any one of these you could do in a half an hour, and less than that if you're in a hurry. So it's a quick project, so if you have a half an hour, you can make one. So it's kind of fun for that reason. It's a little challenging to get them just right. Sometimes they don't work. You try spinning it, and it just won't quite work. So there's a little bit of a challenge to get it just right. And tonight I'm going to show you some tricks that will help to make it so that almost every time they'll work. It's a good practice for making beads, because that's really what you're doing, is just making a bead for the most part. The other thing is my philosophy is small is good for a lot of reasons. One is you don't break your back putting the blank on the lathe. It's pretty easy to put a little blank on. Also, rounding it out is easy. It's just nice making small things. But small things are also nice if you're giving a gift. If you want to just give somebody a simple little gift, a TippeTop is a great one, because everybody loves them. Kids love them, adults love them. In fact, do you want to put that next slide up? Here are some people that have loved TippeTops in the past. You can see Winston Churchill. He used to have a collection of TippeTops. He liked them. The picture up on the upper left-hand corner are a couple of famous physicists, Niels Bohr and Pauli. For the Bohr atom, he's the one that had the first model for a hydrogen atom, and Pauli exclusion principle. They're physicists. And this is a picture taken at a conference when they were fascinated by this tippy top. They were trying to figure out how it worked. So if you like tippy tops, you're in good company. Of course, they magically flip over. That's the main attraction of them. And if you think about their motion from start to finish, it's a bit of a mystery. How do they flip? What's going on? So, so these are all interesting things. It makes it kind of appealing to make, I think. Well, here's a large tippy top I made. You can actually make this work, but it's hard because you have to get it spinning fast, and it's hard to get it going that fast. So when I do it, I go like this, and it wanders all over the place. So I'm not even going to try it tonight. I also sometimes will get a rotary tool. I've got a hole here, so I'll stick something in here, get it spinning real fast, pull it out, and it just spins like crazy, flips over and spins for quite a while. So it actually still works. But what I want to do right now with this is, let's switch back to the picture.
Go back
to me. I want you to show me. Okay, so what I want to do is talk a little bit about how it spins. Okay, so notice on this, can you see the arrows? Here, I'll put it back here. Can you see the arrows on that? I have a piece of tape and put arrows. Okay, so suppose I spin it in the direction of the arrows. Now looking down from top, it's going counterclockwise. Okay, that's what it's doing. Okay, now suppose that I slowly change and move this to make it upside down. Just tip it up. Okay, I keep moving the same direction, right? Everybody agree I'm just going the same direction? Still going the direction of the arrows. Now my question is, did I change the direction of the spin or did I keep it the same? Which one did I do? Keep it the same or did I change it? Same? Does everybody agree it's the same? Well, no, I'm not asking that. I'm just asking, is it the same or different? It's same. Okay, let's say that's the same then. If I spin a tippy top and it flips over, is it going the same direction or opposite direction? It goes the opposite direction. The reason is because when you start it spinning, when it flips over, there's something called conservation of angular momentum. So if you're going clockwise looking from the top, after it flips, it's still going, or I'm sorry, counterclockwise looking from the top. After it flips, it still has to go counterclockwise. But if I make this counterclockwise, I'm going against the arrows. Okay? So that says that a tippy top should change directions. That seems kind of fascinating. It makes it even more fascinating. In other words, if I were a bug riding on this, and you spin it, and I'm moving to the left, after I flip over, I'd be moving to the right. Or another way to say it is, from the point of view of the axis, when you start, it's spinning one direction. When it's up on top, it's going the other direction with respect to the axis. So it's fascinating how it works. Now, we have a video that shows that. Ken, do you want to go ahead and get that started? Okay, so I'm going to talk a little bit while it's going because it's a little bit long. So he spins the tippy top, flips up, does what it's supposed to do. Okay, well, we're going to do it in slow motion now so we can see what happens. Okay, notice it's going against the arrows, opposite the arrows. Okay, now this is a little bit tedious here because it takes like 2 or 3 minutes to flip over. So I probably should entertain you by telling you something about a tippy top. Let's see. I'm trying to think what to tell you. What can I tell you? Why does it work? Well, I can't really tell you exactly why it works because I don't know. If I knew, I'd tell you. But basically, there's a couple things going on. One is, if you look closely at that, when it's spinning, it's not just spinning at a point like this. What it's doing is it's spinning, but it's dragging that point around. In other words, if it's sitting here, when it's spinning in that position it's in now, it's not just spinning at a point. The point in contact is going around in a circle, and that creates friction. Friction together with the pull of gravity is what pulls it up. That's what makes it flip. So you have to analyze that a little more closer, but that's what's going on. If there were no gravity, if there were no gravity, it wouldn't work. But if there were no friction, it wouldn't work. Let's see, it's still got a little ways to go. So, that's a good question. The question was, does it spin the other way in Australia? Actually, I just sold a couple of these to somebody in Australia. And I just sent it out today, in fact. So I wrote a note in there saying, if anybody asks why it works, just tell them it was made in America. So it's trying to get upright with it in America. So, okay, so we're getting close here. We still have a little ways to go.
You would think it would just die at that point, you know, it would just fall over.
Yeah.
Hasn't stopped yet. Oh, it's got a ways to go.
Yeah. Okay, so maybe I can tell you something else. Okay, so when you're making these things, the key is this. This is almost a sphere. It's not quite a sphere. I'll talk about how it's not a sphere in a little bit, but this is almost a sphere. If you take a sphere, the center of mass of the sphere is the very center of the sphere. Okay, let's start watching now because it's about to go. So I'll quit talking a little bit. So far it's kind of been in what I call phase one, and that is it's getting down to where the stem is now starting to touch the surface. Now this is the second phase. Look at it, it just kind of pops up there. And then once it pops up, it sort of catches. Once it catches, it just spins. So I think of three phases. One until it gets touching on, oh, notice it's going with the arrows now. And I don't know if you're watching close before, but there was at one point where the arrows were just, it was going around something like this, and it wasn't spinning along the axis a bit. It was just rotating around like this at one point. But you can see now it's spinning in the opposite direction. Okay? We can go ahead and turn that off now.
Because our point of view has flipped 180 degrees?
Our point of view is the same all the time.
Yeah.
It's because of conservation of angular momentum is the reason. Okay, so what are the what's sort of the key things you have to watch out for to make this work? Ken, you want to do the next slide? While he's getting that, let me say a little bit about center of mass. If you have a sphere, just a regular sphere, the center of mass is the center of the sphere. And by center of mass, I just mean if you look at all the points where there's mass and average where they are, that's the center of mass. So the center of mass will be along this axis, but all of these tippy tops are hollowed and they're cut off on top. So the center of mass is not the center of the sphere, it's lower than the center of the sphere. One before that, right there. Yeah, that's it. So the one before that. Because it never does what you want it to do. I do this in Denton, and I hate it. I do it sometimes in Denton. So I'm not going to criticize you, Ken. Okay. All right. The point there's that black dot there. That is supposed to represent the center of mass. And if you look at it, it looks like it's a little bit below, or a little bit to the below and to the left of the center of the sphere. The key is, to make one of these work is, whenever you set it down on a surface, like that picture, if you take the point of contact and go up in a perpendicular line, straight up, you never want that center of mass to be on that line. It's got to be off to the side of that line. If it's off the side a little ways, it's probably going to work. Okay? Now, of course, you don't know where the center of mass is when you're doing this, so that doesn't help you a lot. But that's really the key. Okay, so you want to do the next slide? I am going to do some turning here in a little bit, by the way. That wasn't, maybe I don't want the next slide yet. Okay, I want people to see me for a little bit now. We'll come back to that one in a second. So the question is, how do you make that center of mass low? And there's several ways of doing it. One way I used to do it, I don't do this anymore, is this is made in two pieces. You have the body and the stem. So when I'm making it, I'm going to drill out a little hole, quarter-inch hole, so the stem will fit in. I used to make it a half-inch instead of a quarter-inch, and I take a little ball bearing, quarter-inch ball bearing, stick it in there. That way you have some very massive material at the bottom that lowers the center of mass. So that worked pretty well. The reason I don't do that anymore is because I have 100 of them, so I might as well use them. So it's not that they're expensive. The reason I don't do that anymore is because to have the mass too low is not good either. Because when it flips over, it's lifting that center of mass, which takes energy. If it has too much energy to get up here, there's not enough energy to spin, and it just falls back. So I quit doing that. So another way to get the center of mass lower is to use two woods, and I think I saved one back here. Here's one. This one's made with Purple Heart and maple. Purple Heart is much denser than maple, so I put the Purple Heart below, maple on top. Center of mass is a little bit lower because of that. And that helps a little bit to make the center of mass low. And that's a nice way to do it because it gives it a nice look too. So that's the second way to do it. The third way to do it, and this is really what you want to do. Okay, now go ahead to the next slide. And that is you make your dimensions right. So here's what I used to just always do this eyeballing them. I can kind of tell based on how wide it is, how tall it should be, you know, to get it about right so it would work. Now what I'm doing is I'm using these numbers. So the way I got these numbers is I made a batch of a bunch of TippeTops, and I took the best 4 or 5, and I looked at certain measurements, and I did ratios, and they all came up very close to the same ratio, the ones that worked well. So the first ratio is, the first distance is D. D would be the diameter of the TippeTop. And then if you take 0.75 D, that should be the height of the body, 3/4 of the diameter. If you take 0.3 D, that would be the distance from the top to this diameter here, at the widest point. And then the total height of the TippeTop should be about 1.1 D, about 10% more than this. So those are the numbers I'm going to be using. So keep those in mind, but I'll remind you if you don't remember, because I know what they are.
Now, is the center of mass going to be just below that D on that? You have the center of
Center mass would be a little below the D there, yeah. Yeah, a little below the D. But I don't know where the center mass is. There's no way to really tell other than do some experiments with it. So you don't know what that is. But these are just, if you use these dimensions, it seems to work well. Okay. Let's go ahead and turn one. Oh, one more thing. I wanted to mention one more thing too that you want to watch for. Another trick to make these work well is the following. It took me a long time to make my first one work right. And the reason it took a long time was because there were a few tricks I didn't know. One trick was on the top of the stem. It can be rounded a little bit, but it can't be rounded too much. If you round it too much, when it flips over, it won't catch. It'll just fall on over. So it took me a long time to realize, make it almost flat. It can be a little bit rounded. It can be concave, convex a little bit. Convex a little bit. It can be concave. It can be flat. But it can't have too much curvature on it. So let's make one. Question?
Does the density of the wood for the stem make a difference?
Yeah, the question is, does the density of the wood for the stem make a difference? And it can, yes. Because you have the mass up here, so you have, if you have a real dense wood, you have a lot more mass up here, and that raises the center of mass. Now, if you make a small stem, it's not going to make too much difference. This one's ebony, and that's heavy, so it does matter. And what I do, and I'll talk about this a little bit more later, is sometimes I will use a stem that's a very light wood. What's it called, gelutong or something like that. I have some of it here, which I may use tonight, or I could use maple. I may use it, though. And that's another thing when you're making these. If they don't work, when you try it with the stem in it, you pull the stem out, you make another stem. So if it looks like it's too dense, you use a less dense wood or make it a little smaller. Okay, so let's make one. I've already marked the center of this. Mark the center any way you want. This is about 4 inches long. It's about 1.5 inches by 1.5 inches. It's not quite square. It doesn't really matter because it'll be round in the end. I like to make tops that are about 1 inch to 1.5 inches in diameter. That seems to work well. If they're bigger than that, then it's hard to spin them fast enough for them to flip. If they're smaller than that, unless you have a lot smaller fingers than I do, they're hard to flip. Okay, so I've got it mounted. What I want to do first is get it, it doesn't have to be completely round yet, but I'm going to get it approximately round and put a tenon on it, and then I'll mount it with a chuck over here. Okay, so let me get these cords out of the way a little bit. Okay, here we go. So I'm just using a roughing gouge, going back and forth, and I'll finish it after I get it on the chuck, but I just want to get it approximately round. Okay, that's good enough for now. And then I'm going to make a tenon on it. So what I use to make a tenon is what I call a tenon maker. I don't know what they're really called, but I just made this. I got a bar of high-speed steel and sharpened it. You can see what the shape is, and you can see that it's at a little bit of an angle. So if I just cut a little bit like that, I've got a pretty nice tenon. So you want to make sure that it fits your chuck. I think that'll fit my chuck. If not, then I'll put it back on and put a tenon on the other side, but I think it should work. So I'll put the chuck in. Oh, the knockout bar. Where's the knockout bar?
John, where's the knockout bar? Right.
Maybe I don't need a knockout bar. Let me see if this will just go in. No, I need it.
I don't see it. We got one coming.
Well, I could knock it out if I had something to knock it out with. Thank you. Okay. Let's put that here. No, that's going to be in the way. All right, I'll put it back here. All right, so this is a Bulldog. I got it at SWAT last year. Well, maybe a couple years ago, I think. Okay, so I'm going to put it in here tight. So I'm going to put my thumb there and just push it straight in. You can put the tailstock up if you want, but I don't think I'll need to because it's only 4 inches, so I'll just not worry about that.
Always keep your elbow on it.
Yeah, maybe I should take that out. It's always a good idea. It's always a good idea to take this out so you don't tear up your elbow or something. Okay. Get that up a little bit higher. Okay. So we get it round. Okay. And now what I want to do is trim the end. So I want to get a good surface here. So that's going to be the edge of the tippy top. And if I get that now, then I won't forget to do it later. So I'm just going to take a spindle gouge, push it here, make sure that the bevel's lined up with the direction I want to go. And that's good enough. I'm going to hollow up through here anyway, so I don't have to have it perfect all the way. Okay, so next step is I want to do some measuring. So, Ken, do you want to put the measurements up again?
I'm going to give it a try. You want it up in the corner if possible?
Put it in the corner if you can, yeah. Because I know everybody wants to see me too. Okay. That's good, yeah. Okay, so what I'm going to do is measure the diameter. That's what's labeled D there, and that's this diameter right here. And I'm going to do it in metric because metric is much easier to work with. It's 37 and a half. 37 and a half. Unfortunately, it's not 36, but that's okay. 37 and a half. So I multiply that by 0.75. Take 3/4 of 37 and a half. Well, 3/4 of 36 would be what? 1/4 of 36 is 9 through 27. So 27, and it's how much more than 36? 2 more. So it'd be about 1.5 more than 27. So 28 and a half is what I want. Now, it doesn't have to be exactly that, so I'll make it about 28. I'll try to do 28 and a half. So what I'm going to do now is try to find my pencil and put a mark there. So I'm measuring from this surface, and I'm going to put a mark right here, and that's how tall the top is going to be. That's the body of the top. So to make sure I don't forget, I'm going to take a parting tool, it's over here, and just take some material out so that I know that's as far as I want to go. Okay. Next thing I want to do is measure from this side into where the diameter, the maximum diameter is. And if you look at that, it's supposed to be 0.3 times D. So D was what, about 37 or something like that? So I need 0.3 times that. So 0.3 times 3 would be about 9, and then a couple more, about 11 maybe, 11 millimeters. Here's my pencil. So I'm going about 11 millimeters. It's about there. And so now I've got the layout of how I want to make it. So now all I have to do is start making a bead. So the first thing I'm going to do is do the right-hand side of the bead. So I'll take my tool, this is my spindle gouge, hold it so the bevel is up, so you can see the bevel, and I'll just kind of start there, start it cutting, raise it, and turn it. Question? Shape of the TippeTop makes a huge difference, but for this part, it doesn't make as much difference. Here, you just want to have a nice curve going down. It's not a big, on the bottom side, it's a much bigger deal, and I'll talk more about that in a little bit. Okay, so let me just go over that another time, get a little better. Okay, that's good enough. Next step is to hollow it. So I'm going to move the tool this way, or the rest this way. The way I'm going to hollow it is I'm going to use the spindle gouge, and I'm going to have it so the flute's at about 45 degrees facing me and up, so it's out like this. And what I'm going to do is push it in like a drill bit, basically, and then I'll just bring it toward me. And I'll do that a couple times and a few times, and it'll be hollow. So I'm going to push it in like a drill bit, pull it toward me. Oh. Now, for the depth, I'm going somewhere near where this line is. You can go a little below or above. It doesn't make a lot of difference, but you want to get somewhere near that line. So I think it's pretty close right there. Now, if you like to hollow in a different way, it doesn't matter. You just need to get it hollow. If you want to, you can go in like you're doing a bowl. I find that harder to do. And by the way, the grain's running this way. You could do it with the grain running this way. In that case, it's easier to do it like you would hollow a bowl. But however you want to hollow, it's fine. Just need to get it hollow. What I like to do next, then, is I use a scoochie gouge. Let me turn this off a second. So the scoochie gouge, if you look at its profile, let's see, where should I put it where you can...
That's pretty good.
Oh. Okay, could you...
Go ahead and raise it back up where you had.
Where or is it from this camera?
See it on the monitor?
Yeah. Okay.
Same color as the tool rest of the
Oh, maybe that's better there. That's better there? Okay. So you can see the side profile there. The top is just kind of angled down, and then the bottom looks like a gouge. And so it's just sharpened. And basically it's just a piece of high-speed steel I got, and I just ground it that way. Now what I'm going to do, though, is I'm going to use it as a negative rake scraper to kind of clean up this hollow a little bit. So I'm going to push it in here in the center, and just real lightly go in. I'm just going in at it straight in. I'm not putting it at an angle much. And this should get rid of a lot of the little lines and things like that that are annoying. Okay, that's good enough for now. I think what I'm going to do next is go ahead and put a 1/4-inch hole in, and that's where the stem will attach to the body. So I've got somewhere, oh, I bet I put it over here. So I've got a 1/4-inch drill bit in a chuck. No, I'm going to make two the question is the stem always a separate piece? No, it's not. In fact, why don't I go ahead and, I've got a couple of these. I'll just, here you go. I'm going to pass those around. There you go. So those, I'm going to make one like this one in a little bit. For that one, it's all one piece of wood. It's all from one blank. But if you want to make one that's a little fancier, like use different kind of woods, you'd want to use this method that I'm using tonight, or right now. Okay, so let's go ahead and drill it. So what I'm going to do is I want a 1/4-inch hole. I want a 1/4-inch deep, or a little more, maybe 5/16. Okay, so there it's just starting to cut, so I'm going to, every time around is 1/16 of an inch, so I want to go 4 times and maybe a little more. Maybe a little faster than that. So I went about 4.5 times. That should be fine. Let's get this out of here so I don't cut myself on it. Now I'm going to actually go ahead and sand it. I know in demos it's kind of boring watching somebody sand, but you can be bored for a few minutes, I guess.
You want to keep those dimensions up there a little longer?
We don't need the dimensions right now. Okay, so I'm going to sand this, and the reason I want to sand it is because I want to put some texture and paint on it, and I need to have a pretty good surface to do that. So I'm starting with the 120 here. I'm going to do the outside here a little bit too, although I don't need to at this point. Okay, so I'll just do this fast. It's a demo piece, so if it's not perfect, it's not a big deal. You'll see how to do it. As long as it flips over, I'll be happy. If it doesn't, I'll be embarrassed, and I'll just leave. Okay, I'm going to 600. I started with 120 and went up through the range to 600. Sand it however much you want. Now what I want to do is use the ELF tool. You can get these at Craft Supply. You can get them other places too, but that's where I got this one. You can also make your own. John Solberg made one that works just fine. Basically all it is just a cutter that's mounted with bearings so it'll spin easily. So what I want to do is turn this up fast. Now what I'm going to do is I'm going to push the cutter up against the surface and just let it roll and see what we get. So that's it. Let me see what it looks like. I'm not going to show you in case it doesn't look good. I'll be embarrassed. No, it actually looks pretty good. Okay, so what I want to do next is use the point tool. Point tool has 3 points on it.
Right in front of the opening. The tip of it right in front of the opening.
Oh, like that. Okay, so you can see there's, I wanted to show like this so you can see there's 3 faces, but that's okay. You can see there's 3 faces, and it's just sharp on the end. Okay, so the idea is, what I want it for this time is I want to put a little groove in there right on the edge of where it was textured. Need to go up a little bit. Let's do it up on this side too. Okay, now what I like to do next is sand it real lightly with a very fine sandpaper. I'm going to use 600 just to take some of the edge off of it. But you don't want to...
Does this count have a hole in the stem?
Okay, the question is, why do I have a hole in the stem on that one? Okay, so let me stop. I'll explain right now. 2 reasons to put a hole in the stem. One is, you can make a Christmas ornament out of it. Okay? So you can hang it on a tree. But that's not the reason there's one in that one. There's something I call a launcher that I make, that I can make. I don't use it, but if you have trouble flipping them, spinning them so that they'll spin over, what you can do is, if you have a hole in it, you can wrap string around it, and then I make this little thing, and I drill it. There's a hole a little bit bigger than the diameter, and if you look at the one with the hole in it, it's shaped sort of like this, and the hole's in here. So you wrap it around so the string doesn't go any more than the diameter, the maximum diameter of the stem. Then you can just put this over the top of it, and if you look, there's a little groove here, so the string will come through that groove, and then you can pull it, and it spins. Okay? So I can say more about this later if you want, but if you have trouble spinning it like that, it works great with this. In fact, you can spin it a lot faster with one of these. Okay, so let's go back to this one. Yeah, so I've got this pretty much the way I want it. With these ELF tools, you get a little brush that's cut off. You can certainly make your own one of these. And I just want to brush it to get all the dust off. And now I'll color it. Now what I like to do with these is use as many colors as I can. I used to think it was nice to use, a color scheme like maybe red and purple, or, just something, 2 colors. But the more colors, the better, because when they spin, as the thing's spinning up, you see all those colors coming one at a time. Whatever happens to be on top spinning, that's what you see. So I like to use a lot of colors. So let's put red on this texture area. Spinning up pretty fast there. And then in those grooves that I made next to the texture area, I'll just use black. Maybe you can see better if I do this. And then I'm going to use blue, sort of on the inside here, like that. Let's see what it looks like. Not too bad. You see that? Okay, so now what I'm going to do is go ahead and finish it now. And the way I finish it is I use wax. I use carnauba wax. And they have carnauba wax here with the Beal buffing system. You can just get, I think you can just get the block of wax here. You can cut it on a bandsaw. Makes your bandsaw work better because it's lubricated. And so cut little pieces, and usually I try to cut them in rectangular pieces like that or something. But I usually drop them and they wind up looking like this.
Hold it down right in front of the opening. I don't have to chase you.
Well, I want to give you a hard time. Okay, so you just rub this on. So you get this going fairly fast. And what I do is I start on the bare wood. Don't go on the color first, or the color will run onto the bare wood. So just do the bare wood first. And then go from the bare wood toward the color. So I'm going to go the bare wood toward the blue. And you always want to look at the end and see if there's any color on it. I don't see any here, so I'll do it again. No color on it, so now I'll go the other direction. This time there's a little bit of color, so I'll just use my fingernail and scratch it off. Start here at this edge and go in. Do it again. So I should have wax pretty much everywhere. So I'll get a paper towel, just any paper towel. It's a little bit dirty, but it doesn't matter. Rub it. And now I can just go over the whole thing. Just doing the inside. Okay, let's see how it looks. Not too bad. Looks pretty good. Okay, so I've got it waxed. I've got the hole. Great. I'm ready to go to the next step. Okay, so now I have to do the other half of the bead. So I did the right-hand side. Now let's do the left-hand side. Do it the same way. Just make a bead. Except you're going the other direction. I'm going to go ahead and use the parting tool so that I keep that distance right. Supposed to be about right there. Now this doesn't have to be perfect yet. I just want to get it approximately right. And that's good enough for now. So I'm going to part it off. And what I like to part it off with is this little parting tool that I made. It's basically just a saw blade that I cut and ground to that profile, and it works pretty good for just cutting small things like this. So there it is. Okay, so the next step is to turn it around so I can get the bottom. So the way I turn it around is this. I'm going to not use a chuck, but instead I'm going to use a collet that takes a 1/4-inch pin. So this is a steel dowel, but it can just be any 1/4-inch piece of steel. Doesn't matter. Fits in the collet. Put it in here. And you tap it in, and that's it. That's what's going to hold it. Now, if you don't have a collet and the pin, you can do it other ways. For example, here's how I used to do it. I made this. I have this threaded. This screws on here, and I just turned this and then drilled a 1/4-inch hole and stuck a piece of steel in there, 1/4-inch piece of steel. Works fine. You can do that. If you don't have the steel, you can do the same thing, except just keep the wood coming out here. So just have a 1/4-inch wood. That works fine. In fact, I might have to do that because sometimes a lathe isn't centered quite perfectly. Oops, I just dropped the wax. The lathe's not centered quite perfectly. It doesn't line up quite right, and the hole's bigger than you want it to be. So let's see if this will stick in here. Yes, it's lined up well. Okay, so that's good enough. It's not. I mean, it's easy to turn and stuff, but it's good enough. It'll be good enough to turn a tippy top. Okay, so I'm going to turn the rest about 45 degrees there, and I'm going to finish it off. So that's the height I want. Maybe a tad shorter, but right about there. So I just want to come in and make a nice curve going down there. Looks pretty good. I think that'll do it. Okay, it's not a sphere. It's shorter than a sphere. It's about 90% of a sphere. So in other words, if this came out another about 10% or so, it'd be the right distance for a sphere. But it's got to be shorter than a sphere to work well. At least that's my experience.
Your drill hole is 1/4 inch, and your little steel dowel is 1/4 inch. Will it spin on itself? Where do you get the friction?
Because they're both 1/4 inch and they just fit. They are. The drill is a 1/4 inch and the dowel's a 1/4 inch. Now probably the dowel's a little bit oversized, or maybe the bit's a little bit undersized, but it works. You can use any bit you want. You can use any dowel you want, and it works. It does seem like it might spin, but it's tight. If they're both exactly a 1/4 inch, it would be tight and tight enough, because I'm not really cutting very far out, so it's not a lot of torque I'm putting on it. Okay, now it's still flat here where the line is. So when I sand it, that'll curve off. So let's go ahead and do that. So I'm just going to sand here. I want to sand at least until the line comes off. And the other thing I want is to make sure that there are no flats, that's a nice smooth curve. So I'm starting with 120, and that's the one I want to really make sure that it's the right shape. I don't want any tool marks, because if you have a groove that goes around there, when it starts flipping over, it may get to that groove and just stop. So you have to be kind of careful about that. Okay. One thing that's always annoying when you have something like this, right in the end here, there's usually a little dot, you know, where the wood kind of pulls out. And I used to worry about that and sand it a lot, but I found a way to get rid of that very, very easily. You know what that way is? Put a little dot of paint on there. Nobody ever notices it. It looks like it's supposed to be like that. Okay, so I'm going to use the elf tool again. 15 minutes. Okay.
Is that right, John?
Okay, 15 or 20 minutes. Okay, so I won't take more than 30. Okay, so I'm gonna put this up close, and that kind of gives a nice pattern generally. If it's not nice this time, that's too bad because I don't have much time, so I can't take it off and do it again. So I'm gonna put grooves around it. Let's color that. We used red. What have we used? Red and blue before. So let's use a purple and a green. So I'll put a green dot on the end here. I'll use purple for the textured area. And I'll use black for these grooves. Okay. Now what I want to do is I want to put a spiral in it. So kind of run out of colors here. What color do you want to use? Let's use blue. I like blue. Okay, so I'm going to turn this and make it go fairly slow, about as slow as I can make it go. Let's do a top view. So it's going fairly slow. What I'm going to do is I'm going to take the pen and I'm just going to slide it across there so I'll get a spiral. Okay? Okay, so here we go. Okay. And then let's go fast here. Put a little more blue here so it looks like it's starting from there. Put a little blue here. Looks like it's finishing there. Okay? All right, let's wax it. Oh, my wax dropped. There it is. It's always good to drop it occasionally because it makes another sharp edge on it. So I'm going to go over the raw wood first. Oops, where there's no paint. A little bit right there. And here where the spiral is, it's not going to smear much, so I'm just going to go ahead and go over that. Go into the colors. Okay, that should be it. I'm hurrying it. So we do it from the top. You can see the, oh, I need to put it here. Okay, so there's what it looks like. Inside and the outside, the end. So the next step is do the stem. Okay, so let's set this aside. And I'll just get a blank. The blank I use, I'm going to use this very light wood. You'd knock this out. So I use this other chuck. It's the same chuck basically, but it has different jaws. This is about, I don't know, maybe it's a little less than a half by half, maybe 3/8 by 3/8. The stem should be about a 1/4 inch diameter, so you want to make sure it's more than a 1/4 inch. You know, you have enough material there to get a 1/4 inch diameter. I want to do a second one after this. That's why I'm kind of feeling rushed. Okay, so what I'm going to do is make the stem. So first get it round. Now, the length of this stem should be about 1.1 times this diameter across where my fingers are. Across where my fingers are. I don't know where you are. Anyway, it's supposed to be about 1.1 times the diameter across my fingers. Okay, you can measure this diameter, multiply by 1.1, subtract this, subtract this difference, add the difference from this edge into the shoulder, and make it work out. but it's easier to do it like this.
Sounds too much like algebra.
It's more like arithmetic. But anyway, here's what I do. I just guess it. So what I do is I put this, the shoulder of it's going to be right along that blue, can you see that? The blue circle. So I'll measure there. And what I want is about 3/8 inch above, so maybe like that. Okay, so I'm just eyeballing it. Now I'll look and see what this reads. It reads in inches, it's about 3/4. Usually it's a little more than that. Yeah, maybe I'll make it a tad bit more than that. Anyway, this distance across there is what I want. So I get my pencil. I forgot one thing. I need to square this off so that I have a good end here. I'm just going to cut it square off if I can. All right, so now I mark it. There's where I want it. I'll use
Which end is going to glue into the top? The right end?
this, where my finger is here, on the right, that's going to be the top of the top. And this part down here, where my finger is now, is going to go into the top, into the hole in the top. Okay, so I need the parting tool. And I cut it about 1/4 inch, not quite 1/4 inch, I hope. And I need a wrench. Ooh, where did I put my wrench? Where's my wrench? Sorry about that. But basically what I have is a 1/4 inch wrench that I sharpened, that I hope is in here. I know I put it in. That's embarrassing. Well, I don't think so. Oh, I'm sorry about that. I hate to measure. If you have a wrench, all you do is you go zip, zip, and you got it right. So that's why I don't like to measure it, but I will measure it.
Yeah, what's in your top pocket? It looks like something's sticking there.
No, that's my inside pocket, and that's my glasses. And I know I brought that wrench. Let me look one more time. Well, this is embarrassing. Yeah.
Little silver wrench, right?
It's a little silver wrench, and it has a magnet on the end, so it might be sticking to something. Okay, I don't need it, though. I can do it without. So I'll just measure it. Where are we here? Just over 1/4. So let's take a little bit off. It should be pretty close. Sorry about that. Normally this takes about 3 seconds. Just a tiny, tiny little bit. Okay, that's it. If it doesn't work, I have some others in a box here we can use. You can see how to make it though. Okay, now what I like to do is make it so here at the end it's about 1/4. Here at the end where you're going to be flipping it, it's about 1/4 inch, maybe a tad less. And at the bottom, I kind of like to flare it out a little bit so that it has a good shoulder to sit in on the top. That's good enough. You know what? I'm not going to sand it and stuff because I'm short on time. Normally I'd sand it, I'd put color on it. But let's not do that tonight. So let's part it off. I'll use this tiny parting tool again. And let's see if it works. Okay. Well, I'm glad I'm done with that one. Okay, yeah, let's just use that bowl. I'll get that in a minute. Okay, hope it works. Whoa, got to get a good spin. There it is. That's a tippy top. Not a bad tippy top, too. It's going for a good while. Okay, do we have enough time for me to make another one? 5 minutes? 5 minutes. I can do it in 5 minutes. Well,
Craig's gonna show us.
don't tell him it's really 10 minutes, but I can do it in 5 minutes. Okay, 5 minutes. I'll do it in 5.
We'll unplug the light after 5 minutes.
Okay, so I'll have to hurry. Okay, so I'm going to start with the same blank I had before, and I'm going to make it all one piece. So the first thing I do, square up the end, because that's where the stem's going to be. Okay, what was the diameter? 37. So how long did we make it? 28, was it? 28? Okay. So 20, let's do 28. Yeah, I got it here. So I'm going to go from this surface here, measure 28. That's going to be the bottom of the top. Fortunately, it's called top, which sounds like the top. Anyway. Okay. We want, from here to the diameter, we want to go, what was it? 3/4, right, of this distance. So how much would that be? Let's see, the diameter was 37. So we're going to go oh, I'm sorry, I said that wrong. We're going to go 3/4 of this diameter. And how much was that? Did I mark this right? I marked it wrong. The total length is supposed to be 1.1 times the diameter. So let me erase that and go 1.1 times that. That's around 40, I think, isn't it? Just under 40. So I apologize. I'm trying to hurry too much. So that's what the total length of the top is, including the stem. Okay, it was 37 and a half. 3/4 of that is what, around 28 or something like that. 28 and a half, something like that. Okay, so I go up that far, and that line is where the stem ends. Okay, then I want to go 0.3 times the 37 or whatever it was, which gives me about 11, and I measure from here and go 11 down there. About there. Okay, that tells the whole story. Now we can just do it. So I have this sort of a wide parting tool. So first of all, I'm going to make the stem. I'll clean up this edge a little bit. Start making this bead. Start hollowing. I'll use the scoochy gouge. The way I'm going to do it is I'm going to take a little bit off the stem. Go a little higher. Push in, pull out to hollow. Go along the stem. Go in a little ways. Hollow. Okay, that's good enough. I'm just doing it fast. I'm not going to sand or anything. Let me mark where the end is supposed to be. That's going to be how long the top is. Right there is going to be the bottom. Let's finish this bead. Now, if you're really good, which I'm not, what you can do is do the whole thing without turning the top around. And let's see if I can do it today. So I'm just trying to get the shape right here. And I'll just part it off with that thin parting tool. And it might work. If it doesn't work, then I'll show you how to fix it. I need to sand this little thing here at the bottom. And I forgot to sand along here, but I think it'll still work. Let's try it. Where did I put the bowl? Here it is. Yeah, it's not working. Okay, so what it's doing is going to a certain point and then it stops. So it's stopping about right here, and the reason is I have a little flat up there. So how do you fix it? Well, I'll show you. How much time do I have?
3 minutes.
3 minutes, okay, no problem. So you go to Home Depot and you get a little bit of a tube, stick it over that.
Which one do you want? Oh,
So you put a little tube from Home Depot on there, and you chuck it in there. You don't have to worry about making marks in because of that plastic tube there. You push it right up against. Probably wobble a little bit, but that's okay. All I'm going to do is sand it, because I've got a little flap there that just needs to come out. Sand it good here. Looks pretty good. I think it'll go now. I don't guarantee it, but it might. Okay. It's not going to go. All right, let me do it really, really hard here and see if that helps. Okay, here's the problem. When you get it right down here, almost where it touches, it just wants to balance there. So what I would do, I don't have any time, but what I would do is mount it again and cut some off right in here. Well, actually more probably right in here is what I think it needs to come off. Because what's happening is that angle there, the curve is too much there. So I think if you were to take a little bit off right there, it'd probably work. And I'm probably out of time. I mean, I'll try it if I have a minute or so.
If you had just gone in a little deeper when you were hollowing
It might have worked.
Reduce it too, wouldn't
It might have worked. If you wouldn't have rushed me so much, I would have gone deeper. Okay, I'll quit. Sorry I couldn't get that last one to work, but with 5 more minutes I could.
Thank you, Neal, very much.
You're welcome.
So if we got some people that can help us pick the chairs up and clean up